problems last week. Okay, we ended on, I believe, molarity and making solutions. Okay. Okay, so we're going to be on the next page. We're going to talk about those solubility rules for a tiny bit, which you guys got a lot of practice on that Friday. Nope, Thursday. I think it was Thursday when we were figuring out our computer stuff. So, okay. Nag-sag. What do we use nag-sag for? People who've seen it. Those are the ones that are usually soluble, okay? Nag-sag are the ones that are usually soluble. You can kind of rely on those for a majority of what you were required to memorize, okay? I've been told don't sit there and be like, okay, I memorize all of them. What it does is they're going to use the most obvious rules, okay, in terms of the AP exam. Now, if you just want to be awesome in chemistry, you should have them memorized, okay? But they're going to stick to the main ones, especially from NAGSAG, with hydroxides and carbonates, all right? And so that's what this is going to help you with. So N just stands for your nitrates. So anytime nitrates are involved, you are soluble. So the minute you see nitrate, soluble. A, ammonium. Not to be confused with ammonia. Ammonium, NH4. Okay, group 1. So group 1 are also known as your alkali metals. Okay, alkali metals keep things soluble. All right, the S stands for sulfates, but we're going to see some exceptions. The other A, acetates. And then finally we have group 17, but that one's going to have a couple exceptions as well. Okay, so we have two little additional rules here. We have the PMS rule and we have Castro-Bear. PMS affects group 17. Castro-Bear affects sulfates in group 17. Nope. Acetates are always. So what PMS stands for is going to be lead. Yes, okay. You're right. Okay. And then Castro-Bear, I kind of highlighted the important things. So you have calcium, some strontium, and you have some barium. Okay. What? Hg is mercury.
Oh, yeah.
I know, it kind of ruins it, right? You're like, wait, what? All right. So these, honestly, if you're comfortable with NAGSAG, you're going to be in a good spot, okay? Because they tell you the ones that tend to usually be soluble. But this little table up here, I also want you to just kind of make sure you become familiar with your hydroxide rules and carbonate. Now, you should get to know all of them, and you will the more you use them, but for sure those two, okay? Sulfides also start showing up, all that good stuff, okay? But if you notice for number 6, the way that one works is that they are insoluble unless they're with a who? Alkali metal, so a group 1 and ammonium, okay? So it's kind of like, I don't actually know. it's backwards. All right. So those things are going to make them soluble, but they're always insoluble. All right. Cool. All right. So when we go to start looking at these, we got silver nitrate. So actually what I'm going to do is I'm going to give you, I don't think it should take you more than 30 to 45 seconds. I'm just kidding, minute. I'll give you 1 minute. Write down all those compounds. What are their formulas? Okay? Get your practice in for that. We'll do the solubility part together. I'm fine with that. All right, so let's talk about whether they're soluble. So silver nitrate. Soluble or not? It is soluble, so I'm going to put yes because it'll make it easier for me. Yes, because it has who?
The nitrate.
The nitrate. Good. Okay. All right. NaCl. Yes, because it has group 1 and group 17. Okay. Lead to bromide. It's no. It's going to be a no. Okay. Pms rule tells us that mixed with group 17, lead is going to make it
Heavy, not soluble.
not soluble. Okay. All right. Ammonium hydroxide.
Yes.
Actually, let me put the rule there so we got it. All right. It is soluble. Good.
Because it has ammonium.
Because it has ammonium. Exactly. So it canceled out the hydroxide rule. Cool. Okay. Barium sulfate.
No.
It's a no. So what's the reason? What rule are we using?
BA.
Castro, very good.
Excellent.
Okay. And then calcium hydroxide.
No.
I would say no.
So whenever it has an OH, it's not soluble.
Hydroxides tend to not be soluble, correct? Unless they're with group 1s. Okay. And then finally, lithium carbonate.
Yes.
Yes, why? Who saves it? Because carbonates tend to be insoluble. So what does?
Group
It's the
one.
group one.
The group 1, lithium, does. Okay, good. All right, cool. So that leads us to the next little bit. We're not going to go through all of these because we'll run out of time. But for your vocab, okay, I'm just going to give you really sweet, simple. If you want better definitions, then go to your book, okay? But molecular, we're going to say is normal, meaning that's what you did pre-AP year. Okay?
Where you just have all the.
Yeah, where you just write it the way it is. Okay? So everything's included, things are combined, you have states of matter. Don't forget, you need states of matter for all of your reactions. Okay? Complete ionic. Normal, but split into ions. So once again, these tend to be the longest ones, by the way. We'll only do it for a couple. So this one, just when things have ions, you're going to split them. Unless they're insoluble, then you leave them together. Okay? And then finally, your net ionic is going to be without spectator ions. Which leads us to the last definition. Spectator ions are the ions not involved with main reaction.
How do you determine which is spectator ion?
I'll show you in just a second. I'm going to cancel it out on both sides. All right. So let's go ahead and write down the types of reactions real quick while we're over here. So synthesis, remember, it's a combination. Okay, that one we're going to get better at
Yes.
together because there's a couple new things with that. Okay, decomposition is one we're going to break apart. A single replacement tends to refer to your activity series. You're trying to bump somebody out. Oh my goodness, what am I doing? B plus AC. Question, does it always have to be the first one that gets bumped out?
No.
No, you can bump out the second guy too, okay? As long as you have an anion with a cation. All right, double replacement. Everybody switches partners. What do we usually use our double replacements for? What type of reactions?
Neutralization. That's the one
I would say the precipitation, ones that make precipitates. Okay, so this is usually when you're trying to make a precipitate. You kind of do it with that too, but this would be the one that I would memorize. All right, combustion. Remember that you usually are dealing with, something combusting in a lot of oxygen. I should not have put carbon and hydrogen, but that tends to be the one that you guys learned first, right? to make carbon dioxide and water. But we're also going to see that if we combust metal in it, we're just making an oxide, making ashes. Okay, this. So that's, yeah. But you have to have this part. You have to have a oxygen, and you have to be making some sort of an oxide. Okay? All right, neutralization. Remember the basic idea here is you're going to have an acid, a base, and you're going to be making usually some sort of a salt with water. Remember, it helps to write water HOH. Okay?
So put HOH?
I'm sorry?
Why do we put HOH?
Acid and base. What?
Why do we put HOH?
Because it helps you actually balance them a little bit easier. All right. So, looking at our first one, I'm going to have to zoom in really close so I can actually write it. Okay, so this wants you to write all three types. So we're only going to do it like that for the first one, and then we'll just decide which one I want you guys to write for the other ones. Okay, so for this first one, we have potassium chloride. So that should be easy enough, right? So KCl plus lead 2 nitrate. What is that 2 talking about again? Yep, it's your charge, so it's the thing that gets crisscrossed. So nitrate has a -1, lead had a +2, so I'm going to throw a 2 on the outside. Okay, so if you notice, they're both partnered up. But most likely, go back to basic ideas, okay? Don't worry about the warm-up today. What would you do with these? Switch them, right? So what type of reaction? Double replacement. Good, all right. So we're going to put potassium now with nitrate. This is where you always check your charges. Make sure you know that. Okay, crisscross them. I'm good. Plus, and then I have lead with a 2+, chlorine with a -, so we crisscross that and give them a little 2. Okay, so a couple things that I'm missing here. First of all, what should I do? Balance it for sure. All right. So that should be 2. Oopsie.
2, 1, 2, 1.
Okay. The other thing is you usually would like to put your different states of matter. So if we're combining two things, trying to make it precipitate, what most likely were both states of matter to begin with? Think about it. We're making a precipitate.
Aqueous.
They were aqueous. Aqueous, remember? Okay. They were in solution. Okay. Potassium nitrate. Aqueous or solid?
Solid.
You guys, it's a nitrate. It's a nitrate. Is it soluble? Nitrates are always soluble. That one you for sure got to have memorized. Nitrates always. So this one is going to be your aqueous. Now lead chloride.
Lead says it all.
Lead 2 chloride. Solid or aqueous?
Oh, solid.
Solid. Good, because PMS rule.
Yeah.
Okay. All right. That's where it comes into play. That's the point of memorizing your rules, is for this kind of stuff. It's
Memorize again. If it's soluble, it's aqueous.
yes. Yep.
But if it's not soluble, it's solid.
Mostly. Yep. Yeah. Yes. Sorry, not mostly. All right. Okay. So now that's our molecular. Okay. So our complete ionic. We're going to split everything. All right. Since these guys are in aqueous, these guys are in solution. That means their ions are split. Okay. It means that in your beaker, for this potassium and chloride, you have some potassiums and you have some chlorines. Potassiums and some chlorines. Does that kind of make sense? Okay, it's not a bunch of things that stick together. That would be a molecular compound. These are ionic. Okay, so when they're in solution, they look like that. That's how it's able to conduct your electricity. That's what makes it a strong electrolyte.
Because they
Dissociated, yep. All right, so for our complete ionic, we would have to show that. You would bring the coefficient with you. I'm running out of room on mine. I'm so sorry. I know I have room up there, but... Okay, so you would bring your coefficient, apply it to both guys. Okay. Lead is also in solution, so I'm going to say Pb with a 2 plus. Plus. All right, what do you guys think? Do we put that subscript, or do you think we're going to turn that into a coefficient for that nitrate? Turns into a coefficient. So we're going to put 2NO3 with a minus. Yields, let me erase this real quick. Maybe not. Maybe so. There it goes. Okay, cool. Give myself some room. All right. And then across the yield sign, we're going to have 2 potassiums plus 2 nitrates plus, you guys told me that last one is solid, so leave those guys together. They are not creating ions. Okay?
So what's the point of separating it?
Because now you're showing all the ions involved. So, one thing I want to point out here, okay? You would also have to include all of your states of matter. Again. Now, we're not going to do that, but you would literally, next to the K, put aqueous. Next to the Cl, put aqueous. Next to the lead, put aqueous. Next to the, okay? Until you get over here, and then you would put a solid. Okay? Yeah, it's pretty painful. So, that leads us to our last type, which is your net ionic, and then we'll speed up, I promise. Okay? So your net ionic, what you need to get rid of is your spectator ion. So it's pretty easy if you write your complete ionic, but most of the time you're not going to want to do that. Okay, so it's going to just be a matter of just building that skill. But looking here, you look at both sides of your arrow, and you see which ones can cross out. You see that you have 2 K pluses, you have 2 nitrates, and then everything else belongs in that net ionic. Those guys were your spectator ions. Okay?
The ones we crossed out.
The ones that are on both sides.
Yeah. So we would end up with, oh man, I'm going to zoom in. I'm having trouble fitting on my screen. Okay. All right, so I'm going to say 2 Cl minus aqueous plus Pb 2 plus aqueous. It's going to yield PbCl2 solid. And that is actually your net ionic. So if you notice, I am still including charges. I'm still including states of matter, and making sure it's balanced. Okay? But you get rid of all your spectators.
So we're going to split them into ions. Is that only going to be for just aqueous? Or?
Yes. Did you guys hear her question? So it's when things are dissolved, they split into their ions. Okay. So, cool. You guys do the next one. Yay. Huh?
All 3?
No, just do oh, yes. I would. Get your practice with one more by yourself, and then we won't do it anymore, I promise. Huh? No, just do letter B, but she was asking, do we want all 3 types of reactions? So I want you guys to try letter B.